Welcome to yet another important class where we're going to look at what is called the Chebychev theorem and the empirical rule. The Chebychev theorem and the empirical rule. Now, when you're discussing the Chebychev's rule, we are looking at a rule in statistics that provides distributions of data within a certain data set. So when we're dealing with Chebyshev, we're looking at a rule or a theorem that provides that a number of standard deviations are going to deviate from the mean at so much. So we have a formula that we need to abide by, which is being depicted here. So when you're doing the Chebyshev's rule, what should always come into your mind is the formula 1 minus 1 over k squared in a percentage. So the Chebyshev's rule, sometimes you'll be asked to explain it. It is a theorem that assumes that regardless of how the data set is distributed, we are always going to have at least 1 minus 1 over k squared times 100 of the values that fall within k standard deviations of the mean. So this is with the assumption that the k is above 0 or above 1. Start from 2, 3, 4 going upwards. So looking at this formula here, let me be simplistic for you to understand. So Chebyshev rule says that we're going to use this rule to understand what percentage we have from the mean. So if we're going to use this table, I want you to help me. And the values of k must be greater than 1. So meaning we're starting from 2. If k is 2, okay, what is our percentage? Using this formula, to be 1 minus 1 over 2 squared. We're going to have what? 1 minus 1 over what? 4. Which is equal to what? 75% or 0.75. Okay. Let's try 3. What percentage under Chebyshev rule will give us the deviations from the mean? So Chebyshev simply gives us how many deviations from the mean we are. So we're looking at a distribution like this one here. So if we have 2 standard deviations here, to this side and to this side, of course this is a negative. So this shaded region is representing how many percentage? 75% from the mean. That's what Chebyshev rule says, that every distribution that is 2 standard deviations from the mean will be 75%. Let's try to go to 3. Let's see. 3. How many percentage are we going to have? So it will be 1 minus 1 over 3 squared. So this is 1 minus 1 over 9. Okay. Please calculate. What are we getting? What are we going to get? 8 over 9, which is equivalent to what? 8 divided by 9 will be 88 point what? 88%. Okay. How about if we had 4? So meaning the area from here up to there is about what? 88.9%. How about if we had 4 standard deviations? We just need to know this formula. Most people don't understand this. It's because they lack what? They perish because they lack knowledge. So the meaning this area here, including what we already have, we're simply going to have 1 minus 1 over, our k is what? 4. So 4 squared. This is 1 minus 1 over 16. This is simply 15 out of 16. So what do we get? 15 divided by 16 will give us 93.75. All right. So this is basically what we're talking about when you're dealing with the Chebychev's theorem. It simply assumes how many deviations in percentage we are. Now, we can even have decimals if you want 2.6, 2.5 in decimals. So now how do questions come? So we're given this question here. If we are doing a distribution, this question has been coming in the exam. You can expect in a test if you like. They guess the questions from here. So we are told that there's a distribution of the prices for the mean prices of a house. So determine what price range will be at least 75%. Okay, let's look at this here. So to start with, I need to take you through brief concepts in estimation. A range is simply given between the mean plus minus what? Minus k. All right, or minus standard deviation in this case that we're looking at. That is our mean. So if you have a mean of, for instance, 10, and the standard deviation is 2, your confidence interval will be between what? 10 minus 2 and between 10 plus 2. So what is your range? 8, 12. That is the range we're talking about. So we are looking at Chebychev's rule in terms of understanding the intervals that we are supposed to be sure of.
Collins, just a minute. The CI, what did you denotes for what? Did you say on the
Confidence
CI?
interval. It's a confidence interval.
Or confidence interval? Okay.
Yes, it's a confidence interval. So for Chebyshev rule, we'll be looking at what? The mean plus minus k standard deviation. So for instance, in this question, we'll be told that suppose the mean is 10 quarter. The standard deviation is 2 quarter. Find the confidence interval for which we are 93.75%. Find the confidence interval for which we are 93.75%. So just to take you back, already we know that 2% is what? 75%. 3% is 88.89%. Then 4% is what? 93.75. So our K at that 93.75, you can master it if you want, is 4. So if we go to this table, we want to find out the confidence interval. So here, confidence interval, where there's mean, we're going to put what? 10. Where there's K, we're going to put what? 4. And the standard deviation we already been given is what? 2 quarter. So here we're going to have 10 plus minus 4 times 2 is 8. So what is our lower bound? Our lower bound will be what? 10 minus 8 is 2. Our upper bound will be 10 plus 8, which is 18. So this is our confidence interval. So I repeat, it's very important that you master this. Our K, we have 2, 2.6, we have 3, we have 3.5 if you want, we have 4. So what was our 2 in terms of percentage when we calculated in there? We found 75%. Remember? What was our 3?
8.9.
At 8.89, correct? What was our 4?
93.75.
And 3.75, all right? If you're not sure, you can manually calculate on your own. Our 2.6, we can calculate. Remember the formula is what? 1 minus 1 over k squared. So I want you to try. Let's find for 2.5. So for 2.5, what are we going to do? 2.6, we're going to do what? 1 minus 1 over 2.6 squared. Can somebody help me? Let's calculate. I want you to be participative for you to enjoy this topic. What are we getting?
85.21.
85.25?
21.
The lady is 3.5. What is it giving you? What is it giving you? Oh, anyone?
91.82.
91.82%. How did you find that? You just did 1 minus 1 over 3.5, right? The power 2.
Correct, yeah.
You found 0.9182. Are we following with the percentage? It is this figure. Are we together so far? Now, a question would come in this case like this. Refer to a distribution of home sales with a mean of 300,000, standard deviation 50,000. Part A, determine the price in which at least 75% of the houses hold. Okay, so what are we given in this question? What are we given in this question? This is our mean. Our mean is what? 300,000. What else are we given?
Standard
Standard
deviation,
deviation.
Which is what?
50,000.
What else are we given? Our K. What's our K?
75%.
So 75% is translating into what K?
2.
2, correct. Then what's the formula? Confidence interval is got what? Mean plus minus what? K and sigma. So here you're going to have 300,000 plus minus 2. And here you're going to have what? 50,000. All right. So this is what? 300,000 plus minus 100,000. Because we multiply 2 times 50,000, 100,000. So what becomes our lower bound? 200. And that becomes our upper bound? 400,000. Are we together? Are we together?
Yeah, we are.
All right. So part B, the question was determine the minimum percentage of houses that should sell for prices between 150 and 450. So in this case, they've given us what? The confidence interval itself. The confidence interval They've given us a minimum is what? 150. The upper bound is what? 450. Although we know that confidence interval is what? Mean, okay, plus or minus K and standard deviation. Okay, we know what our mean is. Our mean is what? From previous example, 300,000, right? And what was our standard deviation? 50,000, right?
Sorry, Colin.
Uh-huh.
This is a continuation of
Yes,
the same question we had.
this is part B.
Okay.
Yes, this is
Oh, part B. Okay.
Mhm.
Okay. Yeah. All right.
This is
It's
part
good.
B.
All right.
So part B, all right, which is simply setting fair to the distribution of home sales with a mean of 300 and standard deviation of 50,000. So now we're being asked to find what? The percentage. All right. So now I'm going to be very clear with you. So which one is the lower bound here and which one is the upper bound? The lower bound is a 50. 150. The upper bound is what? 450.
450.
We're going to categorize them. Which one goes with the lower bound? The negative, right?
Mhm.
Should be equal to 150. And which one is the upper bound? The positive. X plus what? KQ should be equal to what?
Mhm.
450. You can choose either of them to give you the same answer. So now, what was our mean? Our mean was what? From this question, our mean was what?
300,000.
What does mean for 300,000? Plus the K we don't know. The standard deviation was what? 50 what? 1,000. So that's what we want to find the K. Then here we have 450,000 because we're using the plus. So when this one goes this other side, what will happen? It will subtract, right?
Mhm.
To subtract. So 450 minus 350,000, what do we get? Minus 300,000, what do we get?
150,000.
150, correct. So 150,000 divided by 50, what do we get?
3.
So our K will be
So K is 3.
150 divided by 50, which is what? 3. But that's not the percentage. So using the Chebychev, because they're asking us the minimum percentage that will sell for that range. So using Chebychev, 1 minus 1 over K squared, all right? But since my students master this, I like simplifying your life so much. What is 3? Even if we don't do that, you know the table, memorize the table. What is 3?
88.89.
Good, at 8.89. So at 8.89% of the houses will sell between 150 and 450. Wait a minute. How did we use this 450? Why didn't we use this 150 here for the minimum price? I said you can use either of them just to give you the same answer. So for the 150, our mean is what? 300 here. Then when we put here to be a negative, if you're going to use the one for 150. All right, so here we're going to have 300 minus K 50 quads. I'm just scrapping out the zeros in the interest of time. And here to be 150. So this will swap. This one will go this side, this one will go this side. So it will be 300 minus 150 is equal to what? K 150. So here we're going to have 150. Here is K 50, sorry. And here we're going to have K 50. When you divide the K50, we're going to get the same 3 that we found there. Then we use Chebychev, and the 3 will come what? Come to be 88.89. This one, I tell you, carries good marks. Most people leave it out because they have literally no idea. I'll take you to the exam question for last year and the other year. You laugh at how easy this paper was. Yeah. So let's go to the last part. I want you to think with me. I want you to try to determine the minimum percentage that houses should sell for between 170 and 430. The same question. This is part C. Who wants to try? Okay. For the same
We
day,
have the confidence interval.
here we have the confidence interval, correct? Which is between
Yeah,
what?
which the lower bound 170,000
So
and upper bound 430.
good. 170. Let's scrap out the 0 to what? 430. Then our confidence interval in terms of formula of what? Mean plus minus what? K. Yeah, where the mean here is what? 300.
100,000.
Then it's 50. Right? So we can use any. Let's start with the negative part. The negative part will be equated to what? 170, right? Because the minimum. The positive will be equated to what?
430.
430 because it's upper bound. All right. So let's you choose any. So 300 plus 50K will be equal to what? 430, right?
Mm.
Then 50K is equal to what? 430 minus what?
300.
300, correct? Then here 50 is equal to what?
130.
130, correct? Then we divide both sides by what? 50. So what is our K?
Two 2.6.
2.6, correct? And 2.6 by heart is what?
91.872%.
91 point.
91.872.
Okay. Is that what we had? All right. So K, which is what? 2.6. So 1 minus 2.6 squared. You can calculate it if you don't want to memorize, it's still the same. Now together, what do we get?
That was 85.21. Not 91. 85.21.
1. Are we following? Are we together at that moment?
I think that's the one that we found for 2.6.
All right, for 2.6. Okay. Now, let's look at, sometimes you'll come into diagrams, okay? Like this table. They say refer to the table below where we're given, we're told that the following table looks at the number of home runs hit by leaders in their category of the National League 2001. So we have this number. So verify that Chebychev is true for 2 standard deviations around the mean. So let's first understand this question. It was carrying 5 marks. 2 standard deviations around the mean. So how many observations do we have here? We've been told that the mean here is what? 37.9, and the standard deviation is what?
11.
11. Correct. So first, let's come up with what? The confidence interval. There's 7.9 and standard deviation of 11. Let's find the confidence interval for that data. So we've been given the mean and the standard deviation. 11. The mean is what? The 7.9. Then the first part we've been asked to verify Chebychev for 2 standard deviations. So 2 standard deviations, our K is what? 2. All right. So for 2 standard deviations, our K is 2. So what is our confidence interval? Mean plus minus what? K standard deviation, isn't it? So the 7.9 plus or minus 2 in 11. Okay. So this is the 7.9 plus or minus 2 times 11 is what? 22. Right together so far?
Yes.
So the lower bound will be 15.9 and 59.9. 15.9, 59.9. So now this is a confidence interval. So now let's look for values. How many values are? We know that 2%. What's the percentage under Chebychev? 2% should be equal to what?
25%.
How did you find the story recording?
Let's go through it again. Can I go through it again? So we're given this question. We are given home runs. Okay. So we're told, please mute yourselves.
Yeah, I've never seen this from such a.
So we are told that the following table shows the number of home runs hit by leaders in a category for the National League during the 2001 baseball season. So we are given a mean of the 7.9 and standard deviation of 11. And the data set has been given as follows: 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these runs are in total 30. So we've been told that from these 30 observations, we've been given a mean of 37.9 and standard deviation of what? 11. So we are being asked to use Chebychev if it is true for 2 standard deviations. So this 2 is telling us that our K is what? 2. And we know that using Chebychev's rule, our K is equal to 2 gives us 75%. At least 75%. It can be more, but it should not be less than 75%. So far, we're together. So far, we're together.
Yes.
Yes, yes, please.
Yes. Then we went to calculating the confidence interval, which is mean plus minus K. So the mean was the 7.9 there. K was 2. Then the standard deviation was 11. So it was giving us 15.9 to 59.9. So which numbers range within this figure? We need to manually count from 15.9 to 59.9. 15.9 to 59.9. So 15.9, since they're in order, 15.9. So these ones are within 15.9 to 59.9. Up to where? Here. All right. Let's see again. It was from 15.9 to 59.9. Anything within that range we can qualify. So 15.9, these ones are above 15.9. But 59.9, this one we can't put the 64 because it's above 59 and 59.9. So these two are out. So how many are these ones in total? Out of 30, this is 29, right? 28. Since there are 2 outside there. So how many are they? 28 out of what? Out of 30. The ones that qualify. 28 out of 30. So if we calculate them, 28 divided by 30, is it more than 75%? 28 divided by 30. Yes, it's more. It's giving us 93.3. I repeat, the range that we calculated here is just asking us how many observations are there out of 30. Okay, so we need to count manually those that are between 15 and 59.9. So when we go in here, at least 25 is above 15, so already qualifying. But 59.9 up to 57 there. So all these ones are about 28. So when you calculate, let's go through the workings here. So the lower bound was 15.9, the upper bound was 59.9. When you calculate them, they're about 28 observations out of 30. So this one is acceptable because it is at least 75%. So the players will record, therefore, Chebychev is true for 2 standard deviations. Chebychev is true for 2 standard deviations. How about for 3 standard deviations? Is Chebychev rule true?
So Collins,
Mm-hmm.
so you also follow the English, because at least it should be 75 and above, not
Yes, yes, you follow the English.
okay.
25 and above.
Oh,
74,
okay.
we will say no. Chebychev, yeah, fill up. If we found 80,
Oh.
83, as long as it's above 75, at least that is. So let's see for 3 standard deviations if it follows Chebychev's rule. So ready? For 3, remember our K is 3. And what is our percentage at 3%?
8.89.
Good, 88.89. So the figure should be 88.89. So it's very important to master them at the same time so that you don't what? You don't get confused. So now we're using K of 3. And we need to make sure that observations in terms of percentage are at least 88.89. So here we calculate the confidence interval. It will be what? That's 7.9 plus or minus 3, and we put 11 there. So let's calculate. What do we get upper bound? What do we get at our lower bound? Okay. In the interest of time, when you
The
can,
lower bound is
the lower bound will be 4.9,
4.9, yeah.
the upper bound will be 70.9. So when we get this, we'll go here again. Between 70.9 and 4.9. Which ones carry? So 4.9, these ones are above 4.9. And the upper bound is what? 70 point.
70.
So 70.9 we end here. Why not adding the 73? Because above the 70.9. So how many observations do you have?
29 out of 30.
Out of 30. So when you divide 29 out of 30, what are we getting? We're getting
96.7.
96%. So it's above what? 88. So we can say Chebychev here rule will abide. Chebychev rule will abide. Are you together?
Yeah.
All right. So let's look at last year's exam question. This was 2022 November. I'm not I just want to show you that this is where the questions come from. The QM Bible, they ask you, state the Chebychev's rule, 2 marks. Verify Chebychev holds for 2 standard deviations, 4 marks. It's the same question we're doing. We're not going to do it again. Verify that Chebychev holds for 3 standard deviations. All right. 4 marks. Already I've gotten your 10 marks already. This is purely my people perish because of what? Lack of knowledge. All right. So my next class, I'll explain the empirical rule. But for now, I'm going to end here. And this will be your homework. or just screen grab it to you and try it. Ideally,
Sure.
it looks easy when somebody's solving, but I want you to solve as you write in your brain. I'm very happy with your homework. Jeremiah, you sent it to me. Just that I had a busy day today. I'll send after I mark. But we end.
Okay.
All right.